Hey everyone, thanks for tuning in to D News Plus for episode 2 of 5 on formation. If you weren't here yesterday, then you probably aren't aware that we are now D News Plus. We've always been associated with D News, but now we just made it official. Also, check out the new bar at the bottom of the screen. It's pretty awesome. You can click around in the episode and rewatch stuff. It's really, really cool. Yesterday, we talked about how the Earth formed and how humans got on it. Today, we're going to talk about how the solar system formed, because that's kind of the next step backwards. You know, we're working backwards here through kind of the entirety of the universe and how it got here. Now that we know how Earth formed, we can talk about how the solar system formed as a whole. We are not the only solar system, though. You probably knew that, but if you didn't, we're not the only one. Spoiler alert. We're now just beginning to see that there are other solar systems spread around our galaxy, and we've been studying the Milky Way and our own solar system for a long time, and we're just figuring this out because planets are really hard to see, you guys. Really hard. You need to be able to see planets orbiting a sun far, far away in order to determine if you have a solar system or not. And if you don't know if there's a planet there, it's hard to decide when to look at that sun, right? It wasn't until the 1990s that astronomers found strong evidence of planets orbiting other stars. They found planets by detecting their gravitational pull, just a little bit of gravitational pull on the star that they orbit. So think about it this way. If you put a weight on the end of a string and you start spinning in a circle, you would have to lean away from that weight. You know, I don't judge what people do on their weekends, but this is what I do. So you spin around, you lean backward, and you end up, that's what we're looking for in a star far, far away. Another way NASA is looking to find solar systems in far-off parts of the galaxy is by detecting planets that physically pass in front of their star. So essentially, we look at the star and we see a little shadow thing pass in front of it, and that is called a transit, and we look for that, and we can find out what the planet is. Actually, you can find out all sorts of really cool stuff, including what the atmosphere is made of, and it's actually really, really awesome. NASA's Kepler mission is using this observation method, but there's also the French National Space Agency, CNES, and the ESA's Corot mission. Those are looking for these transiting planets and other systems as well. Around 500 different solar systems have been discovered, and we're finding more and more every year. And there are all sorts of candidates that we think might be solar systems that we just have yet to, put that big check mark on. How many are there in our galaxy? It's actually really hard to say, because some estimate that there could be tens of billions of them, or hundreds of billions of them. So, at least they're narrowing it down, right? I mean, we used to just have one. It used to just be us. We thought we were super unique and awesome. And then it turns out, no, there might be hundreds of billions of you. Kind of makes you feel small, Astronomers have concluded that about 10% of the stars in the universe might have a solar system similar to ours. The solar system, that we call the solar system, because we're super good at names, it's not quite as old as the universe, which is 13.8 billion years, give or take. It's only about 4.6 billion years. And there's a lot going on around the universe and around the galaxy and around the solar system all throughout its history. But we're going to just focus right now on ourselves. A lot of this is theoretical. There was no one there writing it down, and we're looking at what kind of things we can still observe today. So one explanation for the formation of the solar system is the collapse of a large molecular cloud made up of a bunch of different elements. So specifically hydrogen, helium, and a few other heavy elements collapsed and fused together. Molecular cloud, by the way, that thing is known as a pre-solar nebula. So those nebulas you see in Hubble photography, those kind of things, big clouds of gas and dust. What caused the collapse, it's not actually known. It could be gravity, it could be nearby supernova or star explosion, it could be, all sorts of stuff. So this baby collapses in on itself, and gravitation starts to take hold of certain chunks of this cloud. This is called the nebular model, by the way. So when objects in motion are moving around a point, in this case light elements moving as they gravitate toward each other and kind of fall inward, they start to rotate or spin, and something called angular momentum takes over. And when that happens, they spin faster and faster. So think like an ice skater spinning. They bring in their arms or their legs and they spin faster. You can do this in your office chair, although I don't recommend it right now because you never know where your boss could be watching or something. But it's basically the concept like that, but on a solar system sized scale. The center of the spin cycle is this little blob. And as more gas falls in toward it, it gets hotter and hotter, and things get crammed closer and closer together, like rush hour on the metro system. Eventually, the center of all this pressure forms into a protostar and has a surrounding disk of gas and dust called a protoplanetary disk or accretion disk. So the planets are formed through a process called accretion in the same way. Those gas and dust disks start to fall toward each other and form planets. So Mercury, Venus, Earth, and Mars are considered rocky planets. They're the inner planets. They're closer to the sun. They're made of metals and silicates because the sun would have basically melted anything with a low melting point, so they have to have the high melting point of those elements so they can form those planets in that location. Water and ice and other gases, they were relegated to the outer planets, where it was a little cooler, allowing cores of bigger planets like Jupiter, Saturn, Uranus, and Neptune to form of ice and other things. Beyond Neptune, out in the Kuiper Belt, things like Pluto could form, chunks of ice and rock mixing together and making all sorts of cool planetary shapes. There's also a lot of asteroids floating around, especially in that area like the Kuiper Belt, but in between Mars and Jupiter, mathematically speaking, there should be a planet. It's not there. Instead, it's an asteroid belt. Now, it's fun to think about, like, maybe there used to be a planet, had this super advanced civilization on it. I've read those sci-fi books too. But it wasn't. It was actually never a planet. It didn't get destroyed in some apocalypse. Instead, Jupiter's gravity, as Jupiter formed, was so high that a planet tried to form and it kept getting pulled apart. Thanks, Obama. Jupiter. Thanks, Jupiter. But we still have all of this gas and dust within the protoplanetary disk, right? Well, at some point, the sun in the middle, the protostar, eventually becomes a fully fledged star. It reaches something called hydrostatic equilibrium. And because its nuclear fusion is so strong, it's able to generate a solar wind, and it blows all of that crap away. The solar wind is essentially the side effect of nuclear fusion happening in the sun, and it creates something called a heliosphere. And then you have a protected little bit of your own little galaxy you can call a solar system. Sounds pretty simple, right? Although, this is just one theory. This is the nebular theory, and it's pretty widely accepted, although there are some problems with it. According to the theory, the planet's axes should all basically be the same because they're all kind of spinning in the same disk, but not all of the planet's axes are the same. There are some other problems with it as well. We just don't know everything about the solar system yet. We're still learning. But what do you guys think of all this? Is this kind of like blowing your mind? Is this too much stuff? Because if so, let us know down in the comments. Make sure you subscribe, and if you want your mind blown a little more, come back tomorrow, because now we're gonna talk about how these solar systems all get together and form galaxies. It's gonna be super cool. So thanks so much for tuning in today. Make sure you come back tomorrow for episode 3 on formation. Come find me on Twitter. You can find me at Trace Dominguez. We'll see you tomorrow.